This video is going to review topics that you should already remember, probably from middle school: mean, median, mode, and range. We're going to add in one new topic, probably in the second video, to talk about standard deviation and how to calculate that. So measure of center is our first definition. It's a measure that represents the center or typical value of a data set. And then we have mean, median, and mode. The mean is the sum of your data divided by the number of data values. A lot of times we'll use n for how many pieces of data we have. And then we have a symbol for this. There's actually two different symbols. And we'll talk about the difference between them. We have mu, which looks like a U with an extra tail, or X bar. And depending on the scenario that we're working with, we might use either one of those. Mu actually represents mean of the population, and then I'm just going to write population mean. So that's when you know all of your information, and then X bar is the mean of a sample. Don't worry too much about the difference between those two right now. We'll talk about that when we get into different data sets. Median is the middle number, obviously when your data is written in order. Kind of encroached on the space a little bit there with my other definition, so I'm just going to box this off. And then the mode is the value or values that occur the most often. And if you think mode and most, we'll start with MO. That'll help you kind of remember which one is which. Our textbook talks about that we can have two modes as long as they both have the equal amount. So if you have 3 of something and 3 of another number, you could say that there are 2 modes, but it has to be the most. So if you have 2 of something and 3 of another, the 3 wins out in that situation. All right, so now we're going to calculate these different things. I'm going to write some of this out, but you don't really have to, because a lot of this you can do in your calculator. So for the mean, which I'm going to label mu, you're going to add everything up. So 16.5 plus 8.75. So what I would do is add all these in your calculator, hit enter, and then divide by how many you have. And we have 1, 2, 3, 4, 5. We have 8. So our n here is 8. Didn't have enough space to fit it all in, so I'm just kind of putting it all there, and we're going to divide that by 8. That's going to give us a mean of 9.65. And we do have some information that might be throwing that number off a little bit, because that's a little on the high side compared to all the salaries. So when we talk about the best measure of center, in this case, that's probably not the best one, based off of the main. We have a lot that are in the $8 range. But let's look at our median and our mode. So our median, if we had our information listed in order, which it's not quite listed in order. We have 8.25, 8.25 are our lowest. The next highest from that's 8.45. So it's actually usually good to list it out in order first, and then you could use the ordered list to do your mean. Sometimes that helps you not miss data. Sometimes, not always. So if we put it in order, and we count from the one side to the other, so we 1, 2, 3, 4, and then 1, 2, 3, 4. This is an even amount of data, so whenever you have an even amount, you're going to average the two middle. If you have an actual middle, you're going to take that number. So our median for this is going to be 8.7. That's a much better measure of center because it's kind of in the middle of that 8 range that we were looking at. And then our mode, we have two $8.25, so that's going to be our mode. Sometimes you don't have a mode, and that's okay. You can say none for that. I think I would say the median is the best representation because it is in the middle. The mean's a little on the high side. And that's really what you're looking for. You're looking for the typical salary and if it's close to that. The mean is a little higher than the typical salary, so we wouldn't say that's a good measure of center. You could argue the mode is also pretty good, although it's kind of on the lower end. So actually, if it's not really in the middle, it's not giving you that good measurement because we have some that are in the 9s that are normal, and then the 16.5 is definitely on the outside there. So we have something called an outlier. There's a way to calculate this if you do box and whisker plots, but sometimes it's just visible. It's a data value that's much greater or much less than the other values in the data set. So if we consider our example here, I would say our outlier is 16.5. It's much higher than the rest, and you can come up with reasons for that. Usually I ask for different reasons of why. Maybe that person has a manager role, has been working there longer, definitely not working more hours because these are hourly wages. Maybe they know somebody, they're the son of the owner of the amusement park, something like that. But this one's much greater than the other wages. If you do the mean without, so if I do the mean without, you're going to add everything up and divide by 7. I'm not going to write this out again. Comes out to 8.67. Now a much better measure of center. The median and the mode stayed the same. Actually, the median's a little different, 8.65, because it becomes the middle number now, and the mode is 8.25. So same. So now if I do recalculate it, now these are both good measures of center when you get rid of that outlier. And then the next question, then this is where we're going to end this video because the next set of information kind of ties together nicely. Possible explanation for the outlier, more responsibility, work there longer. I mean, you could really come up with anything. Like I said, the only thing that wouldn't make sense would be that they work more hours. Tougher job. So sometimes a tougher job doesn't always necessarily mean more pay. It just depends on what that job is. All right, so we're going to end there for now. We're going to talk about range and standard deviation in the next video since they kind of talk about the spread of the data and it's a slightly different set of information that we'll be looking at.